so that was the nth derivative that I just plugged in. Questions? So what is n plus 2 factorial equal to? Jeremy?
N plus 2 times n plus 1 times n factorial.
Good. N plus 2 times n plus 1 times n factorial. And so now I can replace that here, and then I can cancel out the n factorials. Okay, so I have f of x, which in this case equals 1 minus x to the negative 3, equals the sum from n equals 0 to infinity of n plus 2 times n plus 1. Okay, the n factorials cancel out, so I just have over 2, and then times x to the n. Any questions? Okay, so in this packet, okay, I'm not going to go over how to find the interval of convergence because we've already done that. We just apply ratio tests if we want to find the interval of convergence. Okay, and we spent a lot of time on that last week, so I'm not going to go over that, but normally when they ask you to find the Taylor series, they will also ask you to find the interval of convergence. So just so you know, you just apply, like you have done with power series already, and apply ratio test and go from there. Okay? Any questions before I move on to the next example? Okay, so now we want to find the Taylor series centered about the function f of x equals ln x, okay, about x equals 2. Okay, and so now we cannot use the shortcut for this problem because first of all, it's not centered around 0, it's centered around 2. And second of all, we don't know the Maclaurin series for ln x, okay? So we can't use the shortcut. So we have to do the 4 steps. So step 1, find derivatives. So I have f equals ln x. Okay, and then I just take the first few derivatives. I have f prime equals 1 over x, or x to the negative 1. F double prime, okay, I'm going to write as negative 1 times x to the negative 2. And again, when I take these derivatives, I do not want to simplify because it'll just be easier to find the pattern later on if I don't simplify. Okay, so f triple prime, now I bring down the negative 2. So I have negative 2 times negative 1 times x to the negative 3. You have a question?
Yeah, can you simplify the negatives or?
We will on the next part. Okay, and so the fourth derivative, I have negative 3 times negative 2 times negative 1 times x to the negative 4. And let's just do one more. We have the fifth derivative. Okay, so I have negative 4 times negative 3 times negative 2 times negative 1 times x to the negative 5. Questions? Okay, so now we evaluate the center, and the center is x equals 2. So f of 2, now I just plug 2 into x, so I get ln 2. Then I have f prime of 2, which is just 1 over 2. Okay, So then I have f double prime, now I plug 2 in. So I have negative 1 over 2 squared. Okay, now I have f triple prime. So now I have f triple prime. Okay, so the two negatives will cancel. I just have 2 times 1 over 2 to the third. Okay, the fourth derivative at 2 is, there's 3 negatives now, so that cancels out to just 1 negative. So I have negative, of 3 times 2 times 1 over 2 to the fourth. Okay, again, I don't want to multiply through because it's easier to find the pattern when I don't. And then the fifth derivative, I have 4 negatives, that cancels out to a positive. So we have 4 times 3 times 2 times 1 over 2 to the fifth. Questions? Okay, so now move on to step 3. So here, again, I'm going to find the pattern first, okay? Sometimes you find the pattern first, sometimes you plug in first. Okay, you have to use your own judgment of which one will work. If one doesn't work, then just use the other one. Okay, sometimes only one way will work, sometimes both ways will work. Okay, so here we're going to find the pattern. Actually, let me give myself some more space here. Okay, so let's take a look at this for a second. So first of all, notice how, okay, when n equals 0, meaning the 0th derivative, or just the function itself, because if I have the 0 derivative, that means I'm not taking any derivatives. That's just the function itself. So that's when n equals 0, the function itself, okay? And we have natural log of 2. But then the rest of them, so all the other derivatives, okay, we have fractions with no natural log. So it's impossible to find a pattern with this natural log of 2 because this one has a natural log of 2 and the others don't. Okay, so we're just going to treat this function, f, separately from the rest of the derivatives and find the pattern with the rest, leave that one as is. Okay? So when n equals 0, okay, f of 2 is equal to ln2, does not have the same pattern. And again, when n equals 0, that just means the 0th derivative, or just the function itself, f. And so now, when n is greater or equal to 1, we can find a pattern with those, okay? But we cannot find a pattern when n equals 0 because we have a natural log there. So let's find the pattern when n is greater or equal to 1, okay? So here, let's start down here. The numerator is 4 factorial, because I have 4 times 3 times 2 times 1, okay, over 2 to the 5th. Okay, this one is negative of 3 factorial over 2 to the 4th. The third derivative is 2 factorial over 2 to the 3rd. The second derivative is negative 1 factorial over 2 squared. The first derivative is 0 factorial over 2 to the 1st. Yes?
So can you just, like, pattern right from there, like, make it 1 to the n factorial over 2 to the n plus 1?
Right, so that's what we're doing now. We're finding the pattern first before we plug in. Is that what you're asking?
Yeah.
Okay. So when n is greater or equal to 1, we have the n derivative at the center, which is at 2. Now I want to find the pattern. Okay, so give me one thing about the pattern. N minus 1 factorial. Okay, good. Because here we have factorials in all of our numerators. Okay, so here when n equals 4, the fourth derivative, okay, I have 3 factorials. So I subtract 1 and then evaluate the factorial. Okay, same thing here, if I have